and welcome to day 7 of our CCNA training. Okay, today we will talk about 8 subnet and 16 subnet. Okay, in the previous session, like in the session 6, we completed 2 subnet and 4 subnet. And then I gave you homework for the 8 subnet, and I hope you completed your homework. So now I'm going for the 16 subnet. We will use 2 methods. Okay, like first is our classic method to complete the subnet, but it is really very lengthy and it will take time. So for examination, if you don't have time, you can use this second method, and it is really very easy, and we can say that it is a shortcut. Okay, because in the exam you have to give the answer of 102 question within 150 minutes. So like you don't have much time for the calculation and all that. So in this case, you can use shortcut. Okay, and if you are able to understand the shortcut, you will become the master of the subnet. Okay, so pay attention for 1 hour for this session and become master of the subnet. So now I'm going to calculate 16 subnet for class C IP address. Okay, so this is my whiteboard, and the given IP address is 192.168.0.0, and if it is a class C, the default subnet mask would be 255.255.255.0. Okay, and this time I want to create 16 subnet. My requirement is a 16 subnet. Okay, so as we know that IP equal to network plus subnet plus host. Okay, and my requirement is a 16 subnet, but whenever we are talking about class C IP, the network bits are fixed, like it is always 24. So now we have to calculate the subnet. Okay, so the subnet bits are always based on the number of subnet we require. So here my requirement is a 16 subnet. Okay, so we can use this sum, like my requirement is a 16. So 16 equal to 2 power of s. S means subnet bit over here. So let me start with the 2 power of 1. It will create 2 subnet. 2 power of 2 will create 4 subnet. 2 power of 3 will create 8 subnet. And 2 power of 4, it is a 16. So if I want to use, and if I want to create 16 subnet, I have to use 4 bit for the subnet. Okay, actually we are styling this bit from the host, so the remaining bit would be for the host. So 24 bit, it is like a constant, we cannot change it. So the 24 bit would be for the host. We will use 4 bit for the subnet and 4 bit for the host. Yeah, so 24 bit for the network, 4 bit for the subnet, and 4 bit for the host. So if we count this, it will be like number of subnet will be 2 power of 4 and 16, and if we count number of host, it would be 2 power of 4 minus 2, it will be 14. So we will get 16 subnet with each subnet having 14 hosts only. Okay, so now we have to count the subnet mask. So if we count the subnet mask, it would be like 255, 255, 255. This is 24 bits. It is a constant, we cannot touch it. Now 4 bit it for the subnet, so we have to use it 1, 2, 3, 4. 4 1, we have to add 4 ones over here, and here we will add like 4 0 for the host. Okay, so it was in binary, because out of 8 bit, the 4 bit is for subnet and 4 bits are for the host. Okay, so I cannot write this in the binary, so I have to convert this into the decimal. So it will be like 255, 255, 255, and if you count this, it will be 240. Okay, so this will be the subnet mask, and if you count the CIDR mask, it will be like 8, 8, 8, 24 plus 4, it is a 28, or either we can count like 24 plus 4, it is a 28. Now we have to count the range. So how can we count the range? It will be based on the number of subnet. So we use 4 subnet. We use 4 bit for the to create a 16 subnet. Okay. So why we use 4? Because if you are using 4 bit, it has a 16 possibilities. Okay. It will be like 0, 0, 0, 0. Then the second possibilities will be 0, 0, 1, 0. The third possibilities will be 0, 0, 1, 1. Yeah. How can we count this? Just like for the small letter, use like 1, 2, 4, and 8. The first possibility is 0, so it will be 0, 0, 0. The second possibilities would be 1, so it will be 0, 0, 1. Yeah, it will be 0, 0, 1. Let me remove this. So it will be 0, 0, 0, 1. Okay. The third will be 2. So 0, 0, 1, 0. That is 2. Now 3. So it will be 1, 1, 0, 0. So till end, like till 50, you will get the total 0 to 15 means you will get the 16 possibilities. Now let's count the subnet range. Okay. So I'm going to add like subnet 1. And the possibilities we use is this one. Okay. So it will be 0, 0, 0, 0. This is for subnet 1. Okay. Now, if I'm counting range, like starting IP, it will be like first, we cannot touch first 24 bit. So it would be 192.168.0. Okay. And for ending also, we cannot touch it. So it would be like 192.168.0. Now we have to use 4 bit of the subnet over here. So it will be 0, 0, 0, 0, 0, 0, 0, 0. So the first subnet must have all bit 0 as a subnet bit. Okay, and now we will add host bit. So for starting it will be 0, 0, 0, 0, and for ending it will be 1, 1, 1, 1. Okay, now we cannot add this because it is in binary. So let's convert this into the decimal. So it would be 192.168.0.0 to 192.168.0. If you convert this into the binary, it would be 8421. So it will be 15. Okay, and now as you know that this all bit of all host bit 0 is not acceptable. So the starting address will be from 192.168.0.1 to 192.168.0.14. This is where we can use 14 hosts for the each subnet. Now I'm going to calculate subnet 2. Okay, so subnet 2 would be like this. Subnet 1 is using all 0. This is the first possibilities. So subnet 2 will use this 0001. Okay, so just write down, wait a minute, use red. Okay, it will be 0001. So now count the starting range. It would be like 192.168.0, and all will be in the end like 192.168.0. Okay, and now if you use this possibility, we have to add 0001 over here and 0001 over here. And for host, we will use all 0 for starting and all 1 for ending. So if you count this, it would be like 192.168.0. The binary of this would be like 16. and 192.168.0, and binary of this would be 31. Okay, so the range would be like 192.168.0.17. It is a valid range, right? To 192.168.0.30. So on. If you have to map each possibility with each subnet, and you can create a 16 subnet if you are using 4-bit for the subnetting, right? So this is the way we can create a 16 subnet for class C. But if you want to use shortcut for that, we have the easiest way. Okay, so now I'm going to calculate same subnet using the shortcut. Okay, to use this, we have to just, let me open the new page. Okay, now I want to create same subnet, but this time I will use shortcut. So let me count this. Like I have IP 192, same IP 168.0.0. Okay, 255.255.255.0, and the requirement is same again, like 16. Okay, so I will use shortcut for this, like IP equal to N plus S plus H. Okay, given IP address is class C, so it would be 24. For subnet, we have to use 4-bit, you know that, okay? Because 2 power of 4 will get 16, okay? So I will use 4-bit for the subnet. It is the same procedure like a normal way, okay? So here we know that we have to use 4-bit for the subnet and 4-bit for the host. Now count the subnet mask. 255, 255, 255, 240. Okay, now remember this. Whenever you want to count the subnet mask, it would be like, see, if you are able to remember this, it will be very easy for you. Okay, like if you are using 1-bit for the subnetting, subnet mask will be like this: 1 2 3 4 5 6 7 8, and it is always 128, and you are able to create 2 power of 1. You are able to create 2 subnet. If you are using 2-bit for the subnet, it will be 1 1 1 2 3 4 5 6, and the subnet mask would be 192, and 2 power of 2, you are able to create 4 subnet. If you are using 3, you have to use 3-bit for the subnetting. So 1 2 3 4 5 6 7 8. Okay, it will be 224, and 2 power of 3. It means you are able to create 8 subnet. If you are using 4-bit, it will be 1 2 3 4 1 2 3 4. You are able to create, like it will be 240, 255, 255, 255, 240 if it is class C, and 2 power of 4. Okay, it will be 16. 5 1 2 3 4 5 1 2 3. It is 240, and 2 power of 5. It means 32. 6 1 2 3 1 2 3 4 5 6 2 3 4 5 6 7 8. Okay, it will be 252, 2 power of 6, 64 subnet. 2 sorry, you're using 7. Okay, 1 2 3 4 5 6 7 0. It will be 254, and 2 power of 7 will be 128, and 8 1 2 3 4 5 6 7 and 8. It is a 255, and 2 power of 8 can create 256 subnet. Okay, now remember this. Like if you are able to remember this, 128, 2 128 plus 64, like 192, 3 224, 4 to 40, 5 to 48, 6 to 50, 6 to 52, 7 to 54, and 8 is to 55. Okay, so if you are able to remember this, you are able to calculate the subnet mask really very easily. Okay, second thing, in the case of class C, you cannot use more than 6 subnet. Okay, you cannot use more than 6 subnet. Why? Because if I'm going to use 6 subnet, it would be like N plus S plus H. Okay, and N equal to 24. Now I'm going to use 6. Okay, so S equal to 6 and H would be 2. And H would be 2. Right? So if I'm using 6 subnet, I can able to create 2 power of 6. 2 to the power of 6 would be like 2 to the power of 6. I'm able to create 64 subnet. And the number of hosts would be 2 to the power of H. It means we have 2 over here minus 2. So it will be 2 to the power of 2 will be 4 minus 2. So I'm able to connect 2 computers. Okay. But suppose if I'm using 7, it would be like 24 plus 7 plus 1. Okay, yeah, I'm sure it is like I am able to create 128 subnet, but what about the host? Like if I will use 2 power of 1 minus 2, it will be 0 host. So if you are using 1 bit for the host, it means you are able to get 0 IP for the 0 IP for this particular subnet, and if you are getting 0 IP, it means it is useless, right? So if you are using class C, you cannot use more than 6 bit. For using 7 bit and using 8 bit for class C, it is useless. Okay, so just keep this in mind, just remember it. Okay, if you are able to remember, it will be easy for you to calculate the subnet. Okay, now I'm going back to our main calculation. So here it is 240, but now we'll not count the possibilities and all this. We will going for the shortcut. So the shortcut is called a magic number. Okay, the shortcut is called a magic number. Now how to count the magic number? So whatever you are getting in the subnet mask, like if we are using class C, okay, the first 3 bytes are reserved, so I'm using 240, like it is a 4th byte. Okay, for class C it is a 4th byte. So to count the magic number, just count like from 256 minus this particular number, like minus subnet mask. Okay, so it is a 240. So the answer is 16. Okay, the answer is 16. So now you have to jump for the 16. So it would be like the first IP would be 192.168.0.0, and the last IP would be 192.168.0.15. Okay, it is a 15, means 0 to 15. So count 0, count 15. Okay, so it will be 16. So the first IP address would be like 0 to 15, and it will be 192.168.0.1 to 192.168.0.14 will be valid. Yeah, so this is first one. If you want to count second, just start from where you finish for first IP. Okay, for first subnet. So suppose we finish with the 0.15, so we start with the 192.168.0.16. Now add 16 over here. Okay, so 16 plus 16, it will be like, if you are count 16, it would be like 31. So 192.168.0.31. Okay, and the valid would be 192.168.0.17 to 192.168.0.30. So this is the way we can use the shortcut and calculate the subnet within a 2 minutes. Okay, do not need to do not need to create the possibilities list and all this. Okay, it will be really very easy. So now it is like a 16 subnet for class C. Okay, So now I'm going to configure, now I'm going to calculate 16 subnet for class B. Okay, the 16 subnet for class B. Okay, I will calculate again with the two way, like I can use the shortcut and our normal classic method. Okay, so I will calculate over here, so you can able to compare the method. Okay, you can able to compare class C and class B. Okay, so I'm going for the shortcut now first, and then we will, if you want to go for the our classic method, we can go for that. Okay, so like I have IP address, it is 172.16.0.0, and the subnet mask is 255.255.0.0. Yeah, so this is a big difference. For class C, we have 255.255.255.0, but for class B, we have 255.255.0.0. Okay, because for class B, 16 bits are reserved. Now, IP equal to N plus S plus H. Okay, but this time we have class B, so instead of 24, we have to use 16 for the network. Yeah, because in class B, 16 bits are reserved for the host, and for subnet still, like for if you want to create 16 subnet, you have to use 4 bit in any class A, B, C, it doesn't matter over here. So we'll use 4. And for host, now it will be the biggest difference, because see here we have total 8 bit for the host, and out of 8 bit is still 4 bit for the subnet, right? So the remaining bit for the host entry is like 4. So out of 8 we have to minus 4, and the remaining bit would be for the host. But here we have 16 bit for the host, because this is class B, right? And now out of 16 we still 4 bit for the host, for the subnet. So for host it would be like a 12. It would be 12. Okay, so if we count number of subnet over here, number of subnet, it would be 2 power of 4, so it would be 16. And if you count number of host over here, it will be 2 power of 12 minus 2. Okay, so let me open the calc and calculate the 2 power of 12. Okay, it is a 4096, so we can say that we will get 4094, because 4096 minus 2 will be 4094, right? So this is the difference over here. See, we have a 4 bit for the subnet, but it is from out of 8 bit. Yeah, in the example of class C, here we have a 16 bit for the host, so we just still 4 bit for the subnet, so remaining host bit would be 12, right? So now let's count the magic number. Okay, so no, before magic subnet we will count the subnet mask, right? So here the subnet mask would be like 255.255. Now 255.255, and then we have to add a 4 bit of the subnet, so it would be 11111, and then all the host bit were 0, so 1 2 3 4 4, and then again 8, 1 2 3 4 5 6 7 8. Okay, so the subnet mask would be like 255.240.0. Okay, see here we have 255.240, and here we have 255.240.0. Why? Because for class C, 24 bits are reserved, so the all operation goes to the fourth byte, right? And here we have 16 bit reserved, so all the operation will be go on the third byte. Yeah, so here we have 240.0. Okay, and now if you want to find, if you want to count the magic number, it would be like magic number. Okay, 256 minus 240, so it would be 16. Okay, and now count the range. Okay, now I'm going to count the range. So the range would be like 172 16 0.0 to 172 16 15.255. Okay, now this jump will be on the third byte. Here we have jump on the third byte, on the fourth byte, but here we have jump on the third byte. Why on the third byte? Because for class C 24 bits are reserved, and here we have 16 bits are reserved, and we are working with the third and fourth byte. Okay, and now if you count the valid address range, it would be 172.16.0.1 to 172.16.15.254. Okay, so maybe you will be little bit confused when I'm using this. Like if I'm directly going for the shortcut, you will be little confused. Okay, so I will going for the classic way, so you are able to understand this properly. Okay, but let me finish this. Like let me finish the 3 subnet of class B, and then we will use same subnetting using our classic method, so you are able to understand it properly. Okay, so the second will be 172, like we just finished with the 15, so it will be 16.0 to 172.16.31.255. Okay, and now if you count valid, it will be 172.16.16.0 to 172.16.31.254. So this will be the second. Okay, so now maybe you are facing the difficulty that how it is like 01 to 254. Okay, so now I'm going to explain you the same thing with the classic method, so you are able to understand this. Okay, so let me copy this. Let me try to copy this if I am able to copy this. Okay, I will copy this onto the next slide. Wait a minute. See, for any method like you use a classic method or you use a shortcut method, okay, you know that this is like the same. It's like, okay, this is same. Okay, so if we are using the same subnet and everything for the classic method, okay, we are using 4 bit for the subnet. Okay, so we have to count the 16 possibility using 4 bit, so it will be like 4. Okay, and we have 4 bit, so it will be 1 2 4 8, and now use this 0 0 0 0. Okay, 1 1 0 0 0 2 1 0 0 0. Okay, like I just count 3, but you can count like 0 to 50. Okay, so now I'm going to use the classic method, so it would be like, see, the subnet 1, and the possibilities is 0 0 0 0 0. Okay, and now if I'm going to count starting IP address, okay, it is 172.16. okay, because it is reserved. Okay, it is a network bits, so I'm not able to touch it, and the end bit would be 172.16. I'm not able to touch it. Okay, so it will be 16. It will be like as it is. Now I have to use 4 bit, so it will be 0 0 0 0 0 0 0 0. I just wrote 16 bit of the network, 4 bit of the subnet, and now I have to write 12 bit for the host. So it would be like 1 2 3 4. Okay, and 1, 2, 3, 4, 5, 6, 7, 8. For starting, all host bit would be 0, and for ending, all host bit would be 1. Okay. 1, 2, 3, 4, 5, 6, 7, and 8. Now I have to write it into the decimal. Okay, so it would be like 172.16.0.0 to 172.16.0. Sorry, if you convert this into the binary, it would be 15, and if you convert this into the binary, it would be 255. Okay, now this IP address, the first is considered as a network address because all host bits are 0 over here, and this is not valid. Okay, so you have to change one bit as a 1. So suppose if I will use last bit, because I'm counting starting address of IP range, I have to make one over here, and if I will make one over here, it would be 172.16.0.1. yeah, if I'm this is the first, so it is not valid. The second one would be like if you have to change from 0 to 1, so 1, and the second is like last one is not valid, so I have to like 0 over here. Okay, so if I count 0 over here, it would be 172.16.15.254. yeah, 172.16.15.254 would be the valid. So this is a network address, this is the host address, this is the broadcast address, this is valid first IP, and this is a valid last IP. Again, I'm counting for the second subnet, so you are able to understand it properly. This is class B, keep this in mind. Okay, subnet 2, and I have to go for the second possibilities, and it is like a 0, 0, 0, 1. Okay, going to add a starting range. Okay, it is a 172.16. Then the possibility of the subnet, it is 0, 0, 0, 1. Okay, and for ending, it is 172.16.0, 0, 0, 1. And for the host, like 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3. Sorry, I have to write 1 over here. So 1, 1, 1, 1, and 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. So it would be like 172.16. If you convert this, it will be like 16.0 to 172.16. If you convert this into the binary, 31.255. And if you count valid, it would be like 172.16, 16.1 to 172.16, 31.254, because we have to convert last bit from 0 to 1, and here we will convert last bit from 1 to 0, so valid would be 1 to 254. Okay, in the class C, it is like we have to operate directly on the fourth bit, so here they change this. Okay, but for class B, it will not affect over here, it will affect over here. Okay, so this is for class B. Okay, this is for class B. So we just completed a 16 subnet for class B. So now let's create a 32 subnet for class A, B, and C. Like we will create 32 subnet for class C, B, and A together. So you are able to understand the entire subnetting process easily. Okay, so let us do this. I'm going to create for class A first. Okay, I'm going to create for class, sorry, I'm going to create for class C first. So the IP is 192.168.0.0.255.255.255.0, right? and my requirement is 32. Like 32 subnet is my requirement for any. Okay, so 255.255.0 is a default subnet mask. Now if I want to use 32 bit, if I want to create 32 subnet, okay, it would be 2 to the power of 1 will be 2. If I will use 1 bit, I can create 2 subnet. If I will use 2 bit, it will create 4 subnet. If I will use 3 bit, it will create 8 subnet. If I will use 4, it will create 16. And if I will use 5 bit, okay, I am able to create the 32 subnet. Yeah, so I have to use 5 bit for the subnet. Now this is true for any example, for class A, B or C, it doesn't matter. Now IP equal to N plus S plus H. Yeah? So N would be like 24 over here because this is class C, and S would be 5. Okay, and now we have class C. So if you steal 5 bit out of 8 bit of the host, the remaining bit for the subnet for the host would be 3. Okay, if you count the subnet mask over here is a 255, 255, 255, 248. Yeah, remember this: 1, 128, 2, 192, 3, 224, 4, 240, and 5, 248. Now count the magic number. Okay, magic number would be like 256 minus 248. Okay, so it will be 8. Okay, so we have to just count with the gap of 8. So first subnet would be like 192.168.0.02, 192.168.0.7. Okay, 0 to 7 means 8. Count 0, count 7 both. Okay, now here we will get 192.168.0.1 valid and 192.168.0.6. Okay, so 2 to the power of 3 minus 2 will get 1 to 6. Total would be 6 hosts. Okay, this is the first. Now to count second, it would be like 192.168.0.8. Like just start from the last bit, last address of first subnet. Okay, so it is like 8, and it would be like 192.168.0.15. Okay, and the valid would be like 192.168.0.9 to 192.168.0.14. Okay, so this is for class C and the same 32 subnet. Okay, now let's start for the class B. So address is like 172.16.0.0, 255, 255, 255.0. Okay, and now sorry, if it is class B, it would be like 0.0. Okay, so N plus S plus H. Okay, N would be 24. No, we are using class B, so it would be 16. Now S would be same for any, like if you are creating 32 subnet, it doesn't matter for class A, B or C, you have to use 5 bit for the subnet. Okay, and then H. So now out of 16 we are stealing 5 bit for the subnet, so it would be like 11, right? It would be like 11, so total would be like 32. So now count the magic number. Now count the subnet mask first. Be 255, 255. After 16 bit, we will get 248.0. Okay, so no difference, but there is only just we have to operate with the third byte over here. Okay, now count the magic number. Okay, 256 minus 248, so it would be 8. Like magic number is also remain same for any class. Okay, so 8. And now if we are calculating range, it would be like 172 16 0.0 to 172 16 7.255. And if you count valid bit, it is 172 16 0.1 to 172 16 7.254. Okay, so this is the first. Now for second, we have to start from where we left off. Okay, so it is 172 16 8.0 to 172 16 15.255. 255. Okay, so the valid range would be like 172 16 8.1 to 172 16 15.254. So this is for class B. Okay, and now we are going to count same process for class A. Okay, I will not waste your time, so I will do it very quickly. So 10.0.0.0 is the IP, 255.0.0.0. Okay, and if you count N and then plus S and then H. Okay, so over here we have N, so it will be 8 because this time we have class A. Okay, now we have to use 5 subnets, so 5 would be the same as it is, and here we have H. So for class A, there was 8 bit for the subnet, so out of 8 we minus 5, so the remaining bit for the host, and it is 3. For class B, it has 16 bit for the host. Out of 16 bit, we use 5 bit for the host for the subnet, so we have 11 bit left for the host. And here we have 24 bit for the subnet. Okay, so out of here we have 24 bit for the host, so out of 24 we just use 5 bit for the subnet, so the remaining bit would be like 19. Yeah, it will be like 19 bit for the host. Okay, and if you count subnet mask over here, it is 255.255. No, okay, we have only 8 bit reserve over here, so it will be 255.248.0.0. Okay, 24 bit reserve operations are on, operation is on 4th bit, like 4th. Okay, 16 bit reserve operation is on the 3rd, and here we have 8 bit only reserve, so the operation is on the 2nd. Okay, now count the magic number, it would be like same. Okay, 256 minus 248 would be 8. Okay, and if you count this range, it would be like 10.0.0.0 to 10.7.255.255. Okay, and if you use the valid, it would be like 0.0.1 to 10.7.255.254. And here we get 10.8.0.0 to 10.15.255.255, and valid would be like 10.8.0.1 to 10.15.255.254. Okay, so this is the way. And sorry, I forgot to count subnet mask with the CIDR format and number of hosts. So let me count this so you can able to identify the differences. Okay, so here we have 24 plus 5, so the subnet mask, like CIDR mask, would be like /29. Here we have 16 plus 5, so the subnet mask would be like CIDR mask would be 16 plus 5 would be 21. Let me write over here, it will be 21. Okay, and here like, so 24 plus 5 29. and here we have 8 plus 5. Okay, so it would be like 13. Okay, now if you count number of hosts over here, it would be like 3 bit for the host. So 2 power of 3 minus 2. So 2 power of 3 minus 2 would be 6. Here we will get 32 subnet. Here we will get 32 subnet, but each subnet will have only 6 IP addresses. Okay, there will be only 6 hosts you can connect. Here we will get 32 subnet, but like we have 11 bit for the host, so the calculation would be like 2 power of 11 minus 2. Okay, so let's count this. 2 power of 11, okay, would be 2048 minus 2. So we'll get 2046 hosts. So because it is class B, we have more number of hosts. Okay, we'll get 2046 hosts per subnet. Okay, so we'll get 32 subnet with 2046 hosts for each subnet. And here we will get like more. Okay, like 2 power of 19 minus 2. So 2 power of 19. It is 5,24,288. 5,24,286. Yeah, 5,24,286 because we have to minus 2. So this is the way we are able to calculate the subnet mask and the range of the every subnet. Okay, you can use this shortcut. Okay, and like for examination we can create more subnet. Okay, so like we use this for the 32 subnet. Same way we can create a 64 subnet. Okay, but now I want to go for some challenging work for you. So let's do this. Like it is like 64 subnet would be easy for you. Okay, and like 128 would be easy for you also. Okay, so now I want to create 256 subnet. Okay, but if you want to create a 256 subnet, you cannot use class C. So I'm going to use class B. So 172.16 0.0, okay, 255 0.0, because it is class C IP, right? Sorry, it is class B IP. Okay, let me unplug and plug my whiteboard. Like it is really working slow. Wait a minute. Yeah, so now we have a class B IP, and my requirement is like 256 subnet. Okay, my requirement is 256 subnet. Okay, so if I want to create 256 subnet, okay, so I have to use 2 power of 8 would be 256. Yeah, 2 power of 8 would be 256. So if I want to create 256 subnet, I have to use 8 bit for the subnet. Okay, I have to use 8 bit for the subnet. So the scenario would be like the calculation would be like n plus s plus h. Yeah, so n would be 16 class C, and I have to use 8 bit for the subnet, so it will be 8, and there will be 8 bit for the host. So if I will count the subnet mask over here, okay, it will be 255 255 2550. Okay, so here we have 16 plus 8, so the subnet mask would be 255 255 2550. Okay, now let's remember one thing: do not classify a subnet mask. Okay, like if someone is saying that, okay, what is this? You are saying the subnet mask. Okay, what is the class of subnet mask? you cannot say this is a class C subnet mask. Yeah, there is a fixed subnet mask for each and every class. Like for class A, 255.0.000 is default. 255.255.0.0 is for class B, and 255.255.255.0 is for class C. This is true. Yeah, but you cannot say that this is class C subnet mask. Okay, but in our case we have subnet mask, okay, with the 256 subnet. So this is class B, but we are creating 256 subnet, so we have to use 255.255.255.0 IP like subnet mask with the class B IP address. Okay, so never identify subnet mask using the class. Okay, so now we have to use 250 to create 256 subnet. We have to use 8 bit for the subnet, and the subnet mask would be like 255.255.255.0. And now count the magic number. Okay, now this time we have 256, so 255, so 256 minus 255 would be 1. Okay, and if you count this like range, it would be like 172.16.0.0 to 172.16.0.255. It is like class C IP address. The 3 bytes are reserved. Okay, and if you count this 172.16.0.1 to 172.16.0.254, yeah, it is a 0. Like we have to use only one jump, so it is 0. For second it will be like 172.16.1.0 to 172.16.1.255. Okay, I'm not going to write valid because like it is the same pin for everything. Okay, and if we count 172.16 2.0, 172.16 2.255. So the same way we can go from 0 to 255, and we will get 256 subnet. Okay, so this is subnet 1, this is subnet 2, this is subnet 3, and we are just using one jump. Okay, this is the one jump we are using because our magic number is just a 1. Okay, so for class C we use just an entire 8 bit for the subnet. Okay, so even you can create more. Like if you want to go beyond the one entire byte, you can go for the 9 or 10 byte also. Okay, so this is just this example of the 256 subnet. And to create 256 subnet, we just use the entire 8 bit of the third octet. Okay, now I want to make it little bit complex, so I'm going to create a 512 subnet. Yeah, I want to create a 512 subnet. So just calculating over here. Okay, let me remove this, and then I will calculate the same pitch over here. Okay, wait a minute. Okay, I'm doing over here because you can able to compare the process. Yeah. Okay, so instead of 256 with the over here, I want 512. Okay, so if you want to create 512 subnet, you have to use 9 bit. So it would be like 2 power of 9, and the answer would be 512. Okay, so if I will count this calculation over here, it will be like n plus s plus h. Okay, here we can use 16 bit. It is like same for any class B. Okay, and then if you want to use this s, here we have 9. Okay, and out of 60, if you minus 9 bit, it would be like 7. Okay, so now using 9 bit of the subnet, we will get the subnet mask. It will be like 255.255.255.128. See, we are using 9 bit for the subnet now. Okay, and now subnet is like expanded to the third. It is using a third entire bit, and it is also using a 1 bit of the 4th octet. In this case, how can we use shortcut, and how can we count the magic number? Okay, so right now the subnet is telling the entire octet, third octet, and the fourth. And because it is like more than one octet, we have to count the two magic number. And it would be like this. Magic number 1 would be 256 minus 255. Right? So it will be 1. And magic number 2 would be 256 minus 128. Is it a 128? Right? So this is like we are counting two magic number because subnetting is using two octet. Yes, the third octet and the one bit of the fourth octet. Okay, so right now we are having two magic number. So now let's count the range for this. Okay, so we have to use both of this when we are counting the range. So it will be like I'm going to start the first subnet. So it will be 172.16 0.0 to 172.16 0 dot. Here we have this 1 like a 0. Okay, the gap of 1 for magic number 1. And here we will use for the fourth byte, for the fourth octet, we'll use this jump. Okay, so it will be from 0 to 127. So if you count valid, it will be 172.16 0.1 to 172.16 0.126. So this will be the first. But again, we are able to create the second subnet using the same jump of 0. So it will be like 172.16 0.128 to 172.16 0.255. And here the range will be 172.16 0.129 to 172.16 0.254. Okay, so there will be one jump of the third octet will contain two jump of the fourth octet. Okay, so like we will get 256 jump of the first magic number, and there will be a two jump of fourth octet in each subnet. So we will get total 512 subnet. Okay, let's count one more so you are able to understand it properly. So let's go for the second one, like 172.16 1.0 to 172.16 1 dot. Now the jump of this, it will be 127. So 172.16 1.1 to 172.16 1.126 would be valid. Now again the second jump of the fourth octet, it will be 172.16 1.128 to 172.16 1.255. The valid would be 172.16 1.129 to 172.16 1.254. So this is the way you can create like 512. Okay, and if you want to create a 1024, you can use same technique. But if your subnet mask is using more than one octet, you have to count a two magic number. Yeah, so this is the way we can create 2048 subnets. Again, you can go ahead, like you must have to spare at least two bit for the host. This is required, okay, to add the two subnet. Otherwise you can use as much as possible bits for the subnetting. Okay, so this is the end of this subnetting, and tomorrow will be the very important day, because tomorrow we'll talk about which type of the question they are asking. Okay, so if you are going to give exam, they will not ask you the straight subnetting question like this. Okay, they will ask you some tricky question. So tomorrow we'll talk about the questions. Okay, which type of the question they are asking and how to give the answer with the easiest way. Okay, so tomorrow the first topic will be the question, like exam preparation, and the second topic would be what is VLSM. Okay, currently we are doing all this. This is considered as a FLSM. FLSM stands for fixed length subnet masking. And tomorrow we'll talk about what is the difference between FLSM and VLSM, and we will also calculate the VLSM. Okay, so thank you very much for the day, and if you really like this video, please share this, and if you are watching this video into the YouTube, please subscribe this. Okay, so thank you very much for your support. Thank you.